In this video, we're going to be taking a look at all of the different suggested methods for making ice that is completely clear. There are several of them, and some will work and some won't. We'll find out which. Ice is really cool, and of course I mean that in multiple ways, but what's even better is if you can have ice that's completely clear. You can see right through it, but that's kind of a hard effect to achieve. Today we're going to put to the test several suggested methods for how to get clear ice. The basic idea is we'll have a separate container for each of our different methods for making clear ice. We'll let them all freeze and we'll see which ones work the best. Here's what we're going to try. Boiling water, letting it cool down, and then boiling it again is one that I've seen all over the place as a surefire method for making clear ice. Then there's the idea that you can use distilled water, and its complete lack of impurities will let the water crystallize into a nice clear formation. We're also going to try putting some water in our vacuum chamber and letting that run for a while to sort of suck out any extra dissolved gases. Hopefully those won't get trapped in the ice, and that will let us get a clear result. And then finally, we have a small cooler, and we're just going to fill this most of the way with water and put this in the freezer as well and see what happens if we force all of the water to freeze from one direction. In this case, it will freeze from the top down. As a first step, let's fill our small pot with water. We'll boil it, let it cool down back to room temperature, and then boil it a second time before pouring it into this container where we'll freeze it. This one's just distilled water. Distilled water is water that's been run through a distilling process. It's boiled off and the steam is condensed back down into water. And in theory, what you're left with is water that's completely sterile and has nothing else in it. So this should just be hydrogen and oxygen atoms bonded together in water form, nothing else. Okay, now we've got some normal tap water in one of our containers and we're going to vacuum it. Not with vacuum cleaner, vacuum chamber. We hit a low pressure, that's about 25 inches of mercury. It starts boiling and bubbling. And the idea is that by putting it in a vacuum chamber, all of the extra dissolved gases get pulled right out. I'm not entirely sure how that's supposed to work because we're obviously just creating gas by causing it to boil at a low pressure. There could be a level where it pulls out gases before adding more in. Okay, I think our water is good and vacuumed. Now let's take our cooler and fill it most of the way. We'll put that in the freezer and we'll let it freeze. Just to make sure we've really exhausted all possibilities, I took some distilled water, I boiled it twice, and then I ran it in the vacuum chamber for a while so we can get a test of all three of these methods at once. Oh my gosh. Oh, I just have it locked. Here we go. We've got our distilled water, we've got our vacuumed water, and we have our boiled water. I wonder if we can pop these. Oh, yeah, that was easy. Well, it was slightly less easy, but now, first impressions. They definitely all have bubbles in them. I have seen quite a few comments talking about how to get clear ice. If you boil it, that's going to work. You're going to have perfectly clear ice. Well, not really. Here is our twice boiled water. And that has formed ice with bubbles in the middle. I'll give it something. It is not cracked the way that our other two are. That might be a function of the boiling. That might be a function of it had slightly more or less water in it, or its container was just a slightly different flexibility level. There it goes. So with two of these, as I place them under the water, just to try and get more of a clear surface, we got some pretty gnarly cracks that formed. I mean, they already had cracks, but some new ones just popped into existence. Are distilled, are vacuumed, and then are boiled in sort of the order of
most air bubbles and ice damage to least air bubbles and ice damage. However, I don't think that it's necessarily perfectly a function of being boiled. I think there are other factors at play here. For example, I have here a container in which I froze distilled water that I boiled twice, and then I put in the vacuum chamber. So it's all three of these combined, and honestly, it doesn't look any better than the distilled water. And maybe somehow distilled water is just inherently worse in terms of air bubbles. I'm not sure. Let's run this under some water, hope the glass doesn't shatter, and see if we can pop it out. This is a glass container rather than the plastic container, and that very well could contribute to the shape change and all the cracking in there as well. It's spinning in there, but air can't get in there to let it drop out. There we go. Our distilled, vacuumed, boiled puck is, boy, that might be the worst one of all. And that, I believe, is mostly because it was in a glass container, which had no flexibility. So when that ice tried to start expanding, it had nowhere to go but to push itself up more. Of course, if we had tried to seal it in that glass container, it probably would have just shattered the container. Ice does not like to be contained. Let's take a look at our last type of ice, and that's the ice that we put into a cooler. First impressions is I can see some air bubbles down in there, but when I take a closer look, it becomes obvious that we actually have multiple inches of perfectly clear ice before we get to those bubbles. So you can see that those bubbles start several inches down into the ice. They're not immediately up at the top here. And what happened is our cooler made it so that all of the cold could really only go in through the top, or rather the heat could only escape out the top, which means that the top of the ice froze first, and it froze down into the cooler. And after there were a couple inches of frozen ice, or maybe it's less than that, I can't tell because it's going to distort the light a little, but it got a good ways down, and then it froze under that. And that part has some bubbles trapped in it. Those bubbles had nowhere they could go. They couldn't escape out of our container. Let's see if we can get this whole ice block out of our cooler. This could be tricky. Ooh, that sounded good. There we go, there's our block. Oh boy, that's fantastic. So now we can see how much clear ice we're getting out of this. I would say we have 1.5 inches of ice with no bubbles in it, and then we have very, very minimal bubbles for another 3/4 of an inch, and then after that is where the real bubbles really start. Let's see if we can't cut our clear ice off of our white ice. Having melted and chipped away most of the white portion of the ice, you can see how clear we are at this point. Whoa! Let's just set it down here. You can look through it like that. Obviously, there are still some little bubbles in here. And if you wanted to make sure you didn't have any of those, there's a few things I'd recommend. First is actually taking the ice out sooner. Don't let it freeze all the way through, but just have it freeze for the top 1.5 inches or so, and then take the cooler out, take your ice block out, and use it however you like. The way that I've done it is just to demonstrate why we get bubbles in the ice. We get bubbles in the ice because there is gas trapped in the water, and we can't get that out by boiling it or by vacuum chambering it, but it's gonna have gas and contaminants in the water even if we use distilled water, vacuum it, boil it, all of that. But if we freeze it from only one direction, then they all sort of get pushed out of the way, and we get some nice, beautifully clear ice before we get to the portions that are going to cause problems, before we get to the bubbles and stuff, and then those all get pushed to the bottom. So this is the only way that I have found to freeze clear ice at home.